Hi everyone, I hope you're all enjoying GTC and thank you for attending. Just some logistical things, we have a live Q&A running, so don't wait until the end to get your questions in. Get them in now and they'll get answered as we go along. So today we're going to talk to you about the need for secure, private, sovereign translation services in real-time video conferencing for highly regulated industries and governments. We're going to be covering some of the challenges involved, both technical and implementation-wise. We're going to be talking to you about some of the ethical and regulatory concerns in this new area, and also how we can deliver this to anyone on any device, regardless of the platform or ecosystem they choose to use, without necessarily having the latest or greatest devices available. So Ben, can you imagine a world where video conferencing allows us to communicate not just across distances and borders, but also across languages as well?
So where you can kind of collaborate seamlessly and interact with people regardless of what languages you speak.
Exactly. With all of our richness and diversity and unique ideas, being able to communicate without restriction, without boundaries.
And also, can we achieve that but without compromising people's privacy?
I think that would be a pretty nice goal to have, wouldn't you? And I guess we're not the first to imagine this world either, are we?
That's right. Douglas Adams, in his book Hitchhiker's Guide to the Galaxy, which will be known to some of the geeks in the audience, he conceived of the idea of this organism called a Babel fish, which is a telepathic fish that you stuck inside your ear, and it would act as a universal translator.
A universal translator. And I guess in 2024, with the help of Nvidia, we're now extremely close to that becoming a reality, but perhaps without the slippery fish in your ear. So just a bit before we go on, we should probably introduce ourselves. So my name's Ian Mortimer. I'm the CTO at Pexip, and I'm here with my esteemed colleague Ben Hockley, who's a Principal Engineer at Pexip. We've both been around for a while, been sort of 25 years each in the industry.
In some of the same companies?
Some of the same companies, indeed. And we've been working, as I said, we're a world leader, a specialist in secure video communications, headquartered in sunny Norway. And we've been working closely now with Nvidia for several years on this project. So a bit about Pexip ourselves. So we're built on a very unique technology platform that we supply to some of the world's largest governments, industries and bodies in the world. The core of our platform is this very unique server-side transcoding engine. And this engine, this platform allows us to deliver very flexible deployment and connectivity options. So we work extremely closely with Microsoft, with Google, with HP Poly, on bringing any device, any meeting room, any system, regardless of where you are, seamlessly into a call, into a conversation, without any barriers or boundaries. And this can be applied to healthcare situations, judicial situations, government communications, military communications. Anywhere you value secrecy, privacy, sovereignty, compliance, this is where we can help you out. And we do this globally, across the world. And again, this device-agnostic platform that we've built is a perfect match for working with Nvidia's Riva and Maxine technologies. So today you're going to hear about some of the implementation where we bring all of these streams of audio and video information into one place, process it, apply all the amazing technology and bring this cutting-edge AI to anyone, regardless of what they're using.
So, why partner with Nvidia for speech-to-speech translation? Well, one reason is that Nvidia is the clear leader in automatic speech recognition. They're topping the Hugging Face leaderboards, and they support over 60 language pairs, so that, including translating from English and 30 other languages in either direction. So by combining that kind of powerful AI technology with our unique platform, you'll see why we can really make a difference with this technology.
We can. So let's take a look at some of the technical implementation challenges and of translation in some real-world scenarios. And as we said, it's not just about meeting rooms. Of course, that's a big part of this, but translation is required absolutely everywhere, from critical infrastructure projects to disaster recovery to intergovernment communications and lots of other places where you need to get your message across. And human interpreters, they're a very costly and scarce resource because they have a very complex and difficult problem to solve. Every language, for example, has its own idioms that don't translate directly, and you need an understanding of the context and any cultural references. So, for example, Ben, have you ever been told you can't just slide in on a shrimp sandwich in Swedish?
Or perhaps you've had your romantic advances spurned and you've been given pumpkins.
Oh, well. Or perhaps you've embarrassed yourself in front of a room of experts.
As we might be doing now.
So as you can see, idioms are hard, but that's one of the many problems, and they go a lot deeper than that.
So Jeff Hinton is a British-Canadian computer scientist, and he's rightly considered one of the godfathers of AI due to his foundational research back in the 80s in backpropagation in neural networks. He's also a Turing Award winner. So in computer science, there isn't a Nobel Prize. So the highest award that you can get in the field of computer science is a Turing Medal, a Turing Award. Where he lives in Canada, both French and English are spoken widely, but not everybody speaks both languages well. So I like to think that the example he uses to illustrate some of the challenges of machine translation maybe harks back to an experience he might himself have had once. So he likes illustrating the challenge of translation using the trophy suitcase problem.
Trophy and suitcase problem. That's intriguing, Ben. Tell me a bit more about that.
Well, consider the two sentences on the slide. The sentences both describe the same practical problem, namely that the size of the trophy exceeds the capacity of the suitcase to hold the item. So even though the sentences are almost identical, apart from the very last word, the last word changes how we as humans understand the sentence. So in the first sentence, we know that it refers to the trophy. In the second sentence, we know it refers to the suitcase. We can't actually know which item the pronoun it refers to until we've heard the very last word in the sentence, big or small. So we can only make that correct interpretation as humans if we understand something about spatial relations and what is not fitting into what. So this creates a particular challenge not only for machine comprehension, but also for AI translation. In French, objects have gender. There's no single word for it. You can either instead either use il, he, or elle, she, depending on the gender of the object. So the French word for suitcase has the feminine gender, so you would use elle, whereas the French word for trophy has the masculine gender, so you would use the word il. And so the trophy wouldn't fit in the suitcase because it was too big, would translate to
Le trophée ne rentre pas dans la valise parce qu'il était trop grand.
Similarly, to translate the trophy wouldn't fit into the suitcase because it was too small.
Le trophée ne rentre pas dans la valise parce qu'elle était trop petite.
Because the gender of suitcase is different to the gender of trophy, you have to know whether it refers to the suitcase or trophy to select the correctly gendered translation. Even if you're clever enough to figure that out, it's the very last word, big, grand, or small, petite in this case, that has an impact that's reflected back into the middle of the sentence. So you can only translate correctly once you've heard the very end of the sentence. This has an impact in terms of latency, because it means that sometimes there will be small unavoidable delays when people are translating. And this applies to human interpreters as well as AI interpreters. Sometimes you just have to wait until the end of the sentence before you can start translating it to get a correct translation.
So even once you solve the problem with translating idioms correctly and choosing where to place your pronouns and taking into account the genders of things, much like you've seen in the trophy suitcase problem, there's still plenty more that can go wrong. And when you start using these systems in the real world, there are many possible sources of error in the processing pipeline. Many of them are not AI related at all.
For example, just at the input stage, you rarely get completely clean and clear audio. Often there's a little bit of echo, or maybe there's some background noise, or perhaps the speaker themselves is mumbling, or maybe they have an unusual accent. The problems are varied, and it can be exacerbated if you've got a cheap device. They don't sound as good as expensive conference room devices. And just really, these days particularly, not all meetings happen in perfect meeting room situations with perfect acoustics and perfect equipment and a perfect network. The real world is just not that good to us.
No, it's not. And again, text-to-speech itself can also be a little imperfect. Sometimes it can feel a little bit robotic. You lose some of the emotion and some of the tone and intonation you want to get across. You can sometimes lose that.
And even though the text-to-speech systems themselves have that capability of providing intonation now, and they've come on in leaps and bounds the last few years, there's still that difficulty of when you're dealing with this whole kind of translation pipeline of actually inserting the correct emotion at the correct points in a bit of translated text, for example.
Yes. So again, once you've cracked the nut of building the technology to do the translation, to solve all these difficult and complex language problems, how do you actually get it into the hands of the people who need it?
Well, there's a myriad of different devices out there, and with incompatible walled garden ecosystems, for example. You've got Zoom and Teams and WebEx and FaceTime. And looking beyond that, out in the real world, people still use old devices. So your parents' old 8-year-old iPad, for example, won't be able to run heavyweight AI workloads. It's going to even struggle to handling multiple high-definition video streams.
And I guess a lot of the systems as well are, typically they're embedded conference systems in judicial scenarios where you're at the mercy of the vendor who may not want to or can't upgrade the devices, and you're sort of stuck with that technology. It's a very, very challenging problem to solve. Our shared vision is to be able to translate speech within a video conference in near real time to allow participants to communicate without language barriers. So we understand the technology is needed in many different scenarios, but as we've discussed, translation is hard. It's a hard problem to crack. We need these AI features on all types of video conferencing hardware and devices and systems, including dated devices without built-in capabilities to do this. Our solution and this architecture allows us to transparently do the video conferencing and all the AI heavy lifting in the network without burdening the end user devices at all. And with this, we can democratize this technology and make it available to all, regardless of the type of device they're using or their situation. Because this should not just be for the 1%.
Yeah, we don't need to force people to upgrade or replace old working devices. Like video conferencing systems, we can actually avoid cluttering up landfill sites with electronic waste. 45 million tonnes of non-recycled waste, e-waste, are generated every year. So we can cut this, but while still delivering cutting-edge AI features to everyone. And everyone gets a high quality and consistent translation, rather than leaving it to the very variable quality of these technologies on end devices, where different devices might have different amounts of packet loss or different innate capabilities or whatever it might be. Everyone can get that same high quality. So,
yeah, let's take a look at what delivers that high quality. Let's have a little peek into our little media server.
We approach the whole problem of translation with Nvidia Riva and Maxine microservices. There's a 6-stage pipeline, starting and ending with Pexip's world-beating Pulse media stack. That makes sure that the real-time audio stream is handled reliably in both directions, regardless of the audio encoding technology, and it even works in the face of transient network congestion and packet loss.
And you talked about, we talked about before about the clean audio, and not everybody has studio sound and studio equipment. How does Nvidia Maxine help us here?
So Maxine can actually cleanse background noise from the original audio stream, and that will in turn lead to more accurate speech recognition and a lower word error rate. Once you've actually got that audio that's been stripped of background noise, the rest of the pipeline will take care of the rest of the task. So we've got Nvidia Riva, which will then solve the speech-to-text part, the translation part, and also the text-to-speech.
Lovely. So by combining Pexip and Nvidia together into a single transcoding-based system, we've solved both the language translation problem and we've solved the delivery and interoperability problem, and making this work with all these different devices and different ecosystems as we talked about. So now let's tackle some of the other problems. We're around regulation, compliance, ethics and sovereignty and all these complex subjects.
In this messy human world, there's sometimes tensions between international governments. Recent tensions have led to different attitudes to cloud computing in different parts of the world. So there have been worries about protection of citizens' data, as well as national security concerns. The US Cloud Act in 2018 allowed US law enforcement to compel US-based companies to provide requested data. This included from servers that were based on foreign soil, even if that conflicted with the local laws. The Schrems II judgment by the European Court of Justice created new obstacles for European organisations consuming cloud services from American cloud service providers, and stimulated demand for so-called sovereign cloud, that is, cloud providers that are based in the local region or local country. Also, it stimulated interest in self-hosted and air-gapped deployments, but we'll get to that later.
Mm-hmm.
So in the last year or so, a replacement EU-US data privacy framework was put in place that was to try and kind of pour oil on these troubled waters, shall we say. But most commentators are looking at that and thinking that that's very likely to be struck down by the European courts as well. So I think we're still in for some turbulent times, shall we say.
Yes.
But this is a pattern repeated around the world, even between regions that are close allies and close friends. Yep. There's not that kind of complete trust that you imagine there might be. People want to, or countries want to maintain their sovereignty. So data sovereignty is important in Europe. It's important elsewhere.
Yep.
Sovereign cloud adoption or self-hosting is not something that's done lightly. It's pretty expensive. It's quite hard work, kind of setting all of this stuff up, and it can be less convenient than buying cloud services on the global market. But sometimes it's seen as necessary for certain workloads. Not everything, but for some workloads and for some types of data.
Exactly. And you can see here from Jensen's quote when we're talking about sovereignty and Singapore and their desire to build a national AI capability. But this principle applies elsewhere, even at smaller scales as well. But I think the important piece here is the control of your data and also potentially the often overlooked control of your metadata. So tell us a bit more about the metadata problem, Ben.
So metadata is information about who's communicating with whom and the location. Contents of communications is, these days, generally encrypted or even end-to-end encrypted. But metadata is used for actually routing the messages from their source to their destination. So it's a bit like the envelope on a letter. The postman can't read what's inside the letter, but he can see what's on the envelope because he needs to be able to see that in order to be able to deliver it to its ultimate destination. Mm-hmm. And it's the same with messages that are routed over the internet. It's also a bit like telephone records. So if you've ever had an itemized phone bill, you see what number you called and when you placed the call, but the phone company doesn't keep a record of what you said in that call. If you take a step back and kind of look at this at a population level, metadata mining across a population can tell you a lot. You can look at patterns and identify groups of people that are communicating with one another. Within a group, you can identify which person is the commander or coordinator. You can often tell when a big event is about to happen that involves that group because there will be a flurry of communication followed by some silence. And you can tell all of this even without knowing the contents of the communication. But it's worse than you think. As Carissa Veliz, author of Privacy as Power, said, metadata can actually really betray you.
There's some very interesting statistics around this too. Some studies have recently shown that 87% of American citizens can be de-anonymized with just their date of birth, their gender, and their zip code. With just 4 pings or 4 spatial temporal data points, so time and location, we can figure out over 95% of people and just identify that 95% of people just using that information. So some really quite scary tactics.
Terrifying.
But this is also relevant if you're not a spy or a terrorist, for example, but in other situations, knowing who is talking to who can be just as powerful as knowing the content of the call. For example, 2 CFOs are talking together from different companies. Could this imply a merger or some large financial transaction that's about to take place? Or knowing that you've repeatedly spoken to an oncologist may have implications for health insurance or other services. But where your private conversations you think are encrypted or you know they're encrypted, but they could reveal more with the metadata available.
More than you intended.
More than you intended. So you want to control your data and your metadata, But you also need your software suppliers and your vendors to conform to similarly high standards in ways which will protect you. And this brings us on to the subject of software supply chains and secure development life cycles.
Yeah, from a software engineering standpoint, these days you really need secure software development practices. Whole books have been written on secure software development. But despite this, scarcely a day goes by without some new vulnerability being found in a popular software system, with major providers like Microsoft or Adobe or Oracle becoming known for Patch Tuesday, the second Tuesday of every month, when a whole bunch of security updates are released and made available to the customers who need them. To try and break this cycle, one of the things you need is automated software testing. Industry's starting to really kind of recognise this, and there's two big approaches here, or two of the big approaches here are static application security testing, or SAST, and dynamic application security testing, or DAST. Then these are complemented by a third approach called software composition analysis. Now this speaks to something called software supply chain. This is something that's really often overlooked. It's been in the headlines recently with the SEC getting involved with the solar wind scandal. The solar wind scandal showed how software supply chain could be compromised, and how when a supplier of this kind of equipment, of software, got compromised, in turn their clients got compromised, which was a bit of a worry because that included some important government agencies and Fortune 500 companies, household names. So it's but in short, vendors really need to maintain tight control of their components and their software build systems. Every building block needs to have a known provenance, and otherwise there's a possibility that the bad guys could be able to get in.
Yep.
So in Pexip, we take this really seriously, and we've built our own carefully curated and cut down Linux distribution, Pexos, that helps address the software supply chain concern.
And again, you can have the strongest locks in the world on your front door, but if you leave the window open, you're in trouble. You can build the most secure software in the world, but you need to run your network securely.
So Nicole Perroth, former New York Times cybersecurity reporter, reported how in the last few years hackers have shut down hospitals and police departments and infiltrated critical infrastructure such as power grids, dams, and even nuclear facilities. As an extreme measure for protecting critical infrastructure, you might want to disallow external access altogether, as so-called air-gapped networks. But even if you don't go that far, self-hosting your own data and metadata means it's under your control. And so, although air-gapped networks can provide extremely strong protection from cyber attacks, there are other mechanisms as well that are appropriate in other scenarios, and modern approaches like zero trust security. And whichever approach you take there's another thing that you want to consider, which is defense in depth, where you consider every single level of the system with a security mindset to try and make sure that you make life as hard as possible for somebody trying to get in.
So to summarize, people want these AI capabilities, but they don't want to sacrifice their privacy. So control your data and your metadata. We need a solution that respects these concerns while still allowing all devices and systems to connect, to participate regardless of the deployment model, whether that's air-gapped or sovereign cloud. Our architecture and our partnership with Nvidia and our software development approaches solves this problem by building on a secure platform built to the toughest of certifications and regulations in the world.
There is a maze of security certification and compliance and other red tape unique to each country and region. For example, in Europe, you have the GDPR.
And in the US, we have the HIPAA, the Health Insurance Portability and Accountability Act. We have the California Consumer Privacy Act, the CCPA. We have the DISA APL, which is the Department of Defense approved product list. We have FIPS, which is the Federal Information and Processing Standards, and the new AI Bill of Rights blueprint.
And in France, there's the ANSI CSPN, and in Spain, there's the CCN certification.
And countless others.
Countless others.
Yes. And artificial intelligence is changing our lives, and the impact is already significant. So much so that in the current wave of AI developments is seen as a fifth industrial revolution. So it's unsurprising that this level of development has attracted significant attention from regulators around the world.
So, talking about regulation, the European Union is the largest single market in the world. It has over 440 million people. And EU regulation has ripple effects that extend well beyond the borders of Europe. So you know those kind of annoying cookie settings pop-ups that you get everywhere now? That's down to EU regulation.
Sorry.
When it comes to AI, the new EU AI Act requires that AI products be classified according to their risk level. So there's unacceptable risk. So that's AI systems that are forbidden, such as real-time biometric identification in public, for surveillance, for example, or workplace emotion monitoring. Then there are high-risk systems. So these would include systems like self-driving cars or judicial systems or medical AI systems, where you'd actually probably want a little bit of regulatory oversight. But in the EU, these require assessment and registration with the appropriate regulatory body. Then further down the pyramid, you have limited risk systems. So these are systems which are permitted, but may come with certain transparency requirements and obligations. So a big kind of thing here is that AI can't pretend to be human. Humans must always know when they're interacting with an AI-powered service or AI-generated content, for example, a customer service chatbot. This is relevant to some of our AI-powered speech-to-speech translation services, we think. Then right at the bottom of the pyramid, there's the really low-risk systems where we've had kind of flavors of them for a number of years already, and there's not a huge problem. So things like email spam filters, that kind of thing.
Yep.
Whereas over the pond in the USA, we of course have the world's #1 economy, and it's the home to many of the key players in AI. And whilst there is state-by-state legislation kind of emerging in dribs and drabs, one of the most significant steps forward in regulation is the White House blueprint for an AI Bill of Rights. So this promises a right to safe and effective systems, to algorithmic discrimination protection. So you should not face discrimination from biased algorithms or AI models. There's also some data privacy stuff here. You should be protected from abusive data practices and have control over how data about you is used. And then there's a notice and explanation clause here too. So as in Europe, it should be really clear when and how AI systems are being used. So you should know when you're using one. And there should be help for you to understand how and why it impacts you. And uniquely in the USA, there's this kind of requirement to offer alternative options where appropriate. So for example, you might need to be offered the opportunity to speak to a human instead of a chatbot, or you might need a human contact that you can get hold of if there is a problem with the AI system that you're using. So as you can see, there's a lot of commonality that both the EU and US regulations address common real-world problems. Academics from 3 of the top universities in the world did a mass of research about AI projects that had gone well and those that had not gone so well. And they identified that the biggest failures relating to mass adoption of AI services to date have involved privacy. So where users share data with an organization for one purpose, but it's then been used for another purpose. So a prominent example here is the Cambridge Analytica scandal, which led to some of the biggest regulator-imposed fines in history, because that was actually kind of covered by existing privacy legislation. But another major failure category here is when AI systems show bias against a particular group. And then the third biggest failure category is around replication or explainability, when an AI system produces unexpected outputs.
And this is a very interesting area, because how can you explain why an AI system behaved in a certain way, particularly if it's made a mistake or a certain assumption? This is very hard with deep learning systems. So if you ask an AI to translate the word doctor, relatively simple for humans, sounds quite simple, but there are a host of cultural implications and other issues that are exposed by using these systems.
Yeah, so AI systems can accidentally reinforce social, racial, and gender biases. This is not really so much because algorithms themselves are biased, but rather because AI training data is often reflective of the world we live in, and the world we live in still has many biases and unfairnesses. In Invisible Women, author Caroline Criado Perez reports that about a big speech recognition system, major speech recognition system, which was found to work much better for men than for women. And that turned out to be because the corpus of training voices that were used was predominantly male voices. So the poor system just hadn't learned to hear female voices properly. So that's an example of the kind of thing that you need to look out for when building systems like this. But when it comes to translation, there's a number of other problems. So one such problem is the default male problem. So that's where use of male pronouns by default in translating runs the risk of accidentally kind of erasing women from the conversation. So there may be embedded cultural stereotypes, for example, doctor equals man, nurse equals woman. And in English, the distinction isn't really there in the vocabulary, but in other languages, you might have a different word. So, for example, in Spanish, doctor is a male doctor, doctora is a female doctor. An AI system translating from English into Spanish won't necessarily know which is the right word to use unless it has access to a much kind of greater context than just the word itself.
So zooming out, there's some implications of adopting AI translation. So as we move to democratize AI services, we'll be able to deliver them to a vastly greater number of people for good. But we will start to see human translators making increasing use of these AI services to assist with their work. And looking beyond this, there are potential risks of de-skilling human translators.
Yeah, we also have to pause to acknowledge that we are at the beginning of another industrial revolution. In this revolution, AI will augment some existing job roles, and it will also create some new jobs that maybe we hadn't thought of yet. But yes, it will also trigger some people to transition to new roles as old roles are changed forever or displaced by new technology. So this is something that requires thoughtful and considered approaches. There are also risks around, in the early days, over-reliance on potentially imperfect technology in sensitive situations. We'll have to be careful about what context the new technology gets applied in. But over time, as AI capabilities develop and advance, so the number of appropriate contexts where it's safe to use these systems will expand too.
Yep. And there's also potentially a problem for increasing processing minority accents and regional accents and certain dialects in different languages. There could be cultural and political implications. Some communities or populations or regions are not able to benefit from these amazing new advancements in AI. Existing inequalities and disparities could be reflected into this future.
So it's likely that human interpreters will be necessary for the foreseeable future in many high-risk and high-stakes or complicated situations. But finally, there's this Babelfish problem. So in Hitchhiker's Guide to the Galaxy, in a darkly wry, humorous twist, Douglas Adams observed that by removing all barriers to communication, the Babelfish actually caused more and bloodier wars than anything else in the history of creation, as it left no room for misunderstanding. How many times has the judgment of a tactful human interpreter helped avoid conflict and strife?
We'll never know.
So before we move on to the next section, a quick sidebar on compliance. There's a lot of complexity around regulatory compliance, but luckily there are frameworks in place that can help and guide vendors on their compliance journey. We sadly don't have time to dig deeply into the CAP AI procedure, which is one such framework, developed by the same top universities that did the research we mentioned a few slides back. But we believe that this framework could be super helpful to you if you're a vendor of AI systems and you don't know where to begin in your quest to conform with the new AI regulations around the world. If you're not sure where to start, you could do a lot worse than starting here.
Yep, exactly. So, to summarize, choose a product that's built from the ground up to conform to these strict, stringent security standards. Choose an AI vendor that has an ethical approach to AI adoption. And operate your system in a secure location, in a secure manner, with the appropriate jurisdictions to ensure proper control of your data and the often overlooked and very important metadata.
So, in summary, we've seen that there's huge untapped demand for AI services like translation, with massive benefits for society. We'll soon be able to translate seamlessly between languages in real-time video conferencing, regardless of barriers around different devices and systems. We've covered the importance of controlling not only your data, but also your metadata. and how privacy and sovereignty are key for many customers and many types of workload. And we also touched on the complex regulatory frameworks and the increasing focus regulators are bringing to this area.
Yes. So together with Nvidia, we are building the foundational platform for all of your secure and private AI services, whatever that may bring. Today, that's translation in video conferencing. Tomorrow, with this platform we built together and the ability to bring all of this rich video and audio data into one place securely, we'll be able to bring all kinds of amazing and useful features like gaze correction, video effects, avatars, super resolution, and so much more with the power of Maxine and Nvidia's world-class AI. So if all of this sounds interesting and you care about privacy and sovereignty, please reach out to us and we look forward to working with you in the future. So thank you for attending. Thank you for your time. We appreciate it and see you all very soon.